Hey beautiful people, welcome back to my channel. My name is Busisiwe Dlamini Kharodi, the King Path Principal. In today's episode, I just want to do a few examples of calculating dilutions, or of how to go about with dilutions. So I'm just gonna do two questions and try to work them out. Hopefully they will be able to assist you. So the first question that I have, it says you have made a dilution So this dilution that you have made, you have mixed 300 microliters of saline with 0.1 ml of serum. Serum, and then a serum urea of 5.9 was obtained from the dilution that you have made. So it means this dilution was ran on an instrument for urea, and the value that was obtained was 5.9. Not 5.9, 5.7, I mean, millimoles per liter. So now the question is, what is the final results? So firstly, what we are going to start with in this question is to determine the dilution factor that we can use to be able to multiply and calculate our final result. So the first step in this, it's looking at your question. It says this dilution that you have made, you have used 300 microliters of saline. So in this case, the saline will be your diluent, and 0.1 mils of serum, which will be your solute, or what you want to dilute. And again, another important factor here is that with mathematics, you cannot always work with units that are not the same. So the first thing that you always have to do is to make sure that your units are the same. So in this case, you can choose whether you're going to convert your microliters to milliliters, or you convert your milliliters to microliters. So in this case, what we are going to do in our case, we are going to convert the milliliters to microliters. I like to work with whole numbers instead of decimals, especially if I have an option. So in this case, I do have an option. So the first step, it will be to convert that to microliters. So going back to our conversions using exponents, so it means we have 0.1, and then we are moving mils are bigger than microliters, so it means we are moving down. So we are going to multiply by moving from mils to microliters, you move by 3 zeros, so it means we have to multiply by 1,000, and then we're just gonna punch that onto the calculator, and then you're gonna end up with 100 microliters. So now your units are the same for your diluent as well as for your serum. So now you can be able to determine your dilution factor. So to determine the dilution factor, your serum will always be on top. If you remember the dilution statement, it's always, for example, like this with a straw, and we know that the top part becomes your solute and the bottom part will be your total volume. So we're going to express this the same way. So we're going to have, let me use a different color. So we're going to have 100 microliters, which is your serum, over the total volume. Now it means you're going to mix the volume of your serum as well as your volume of your diluent, and then the total volume gives you 400 microliters. But then for us to be able to get a dilution factor, we have to simplify our fraction. So to simplify our fraction, you're going to say, okay, 100 goes once into 100, and then it goes 4 times into 400. And then we're going to end up with 1/4. So this is our dilution statement. So once we have determined our dilution statement, it means now we know that our dilution factor is 4. So since now we know our dilution factor, now we can be able to apply it. So the question basically here, what they want, it is the final result. So it means in this case, probably your machine reached linearity and you couldn't be able to find the result. So what you did was to make a dilution. So in this case, you did a 1/4 dilution. So after practically diluting your sample, what you did, you ran it on the instrument, and then the result that you got is 5.7. But that 5.7, it's not what is represented in the patient's body. It's not what is happening in the patient's body. It's a result that you got after you've mixed your solution in vitro. So now you need to give the doctor a result. So to be able to give the doctor the result, you're supposed to multiply the result that you got from your diluted sample with the dilution factor. And then the result that you're gonna get will be the result of urea that is represented in the patient's bloodstream. So it means we're gonna have 5.7 multiplied by 4, which gives us 22.8 millimoles per liter. So this is the result that you are going to report, that you're going to send back to the doctor. So basically that's your final result, and then you are done with this question. So the first thing that we needed to do was to make sure that our units are the same. After making sure our units are the same, we wrote down our dilution statement, and then we were able to get a dilution factor, and then from getting a dilution factor we were able to get our final result, because we multiplied the result that we got from the machine, from the diluted sample, and multiplied it by our dilution factor, and then we got a final result. I hope that makes sense. So let's do another example. So basically, this is how usually the dilution questions are asked in an exam. So the other question that you can get, or a different way whereby you can get a question about dilution, they will ask it like this: how would you prepare a dilution? So like, how to prepare a 1/6 dilution with a total volume of 120 microliters. So in this case, they've given you the total volume that you must use. So you must take it into consideration. You can't just mix. So what you are going to do, as we know that our dilution statement is always our 1 part of the solid over total volume, or over the total. So now they have given us the total volume that at the end in our tubes. So if this is your tube, it means the total must be 120 microliters. So when you have mixed your serum and your saline as a diluent, the total must be 120. So that's what we have. So what we do not have, we don't know, is how much of the serum must we use and how much of the saline must we use. So we need to determine that. So to be able to determine that, we're going to use ratio and proportion. And then with ratio and proportion, we know that this is how we're going to write our dilution statement. So we're going to have X on the other side, which is going to represent our solid, our final solid. And then we're going to have the 120 at the bottom, because we know that our bottom part, the denominator, it is always our total volume. So what we're going to do, we're just going to cross multiply And then at the end, we're going to end up with 120 divided by 6. And then our answer becomes 20 microliters. So it means now for us to be able to do this 1 in 6 dilution, we're going to use 20 microliters of serum. But remember, we still need to know how much of diluent are we going to use, because the question is asking you how are you going to do it. So your answer doesn't end here. Then how are we going to determine the amount of diluent that we're going to use? So we're going to take the total volume minus the solute, then it's going to give us our diluent volume. So 120 minus 20, we get 100 microliters. So it means to prepare a 1 in 6 dilution, you're going to use 20 microliters of serum plus 100 microliters of saline. And then, like we said, both they give you the total of 120. So basically now you have answered the question of how are you going to prepare this dilution, taking into consideration the final volume that you are given. So it means your total volume can never be greater or less than that, because they are specific to you on how much you must have at the end. And then now the question says now, okay, you ran your enzyme result, and then it was out of linearity, and then after you did this dilution, you ran it. After running it, you got a concentration of 49 millimoles per liter. Then they ask you what is the final volume. So now they want to know the results that you are going to report on your LIS system. So it means now you're going to take this 49 multiplied by 6, because your dilution factor is 6. So now we don't have to calculate the dilution factor, because the question told us that we must prepare a 1 in 6 dilution. So we already know it, it's given. So it's going to be 49 multiplied by 6, and then your final result is, it will become 294 millimoles per liter, and then you get your full marks. Thank you so much for joining me. Hopefully you get it, but if you have any questions, feel free to ask me in the comment section. I will try my